Dear students, in the last session I had explained the AM demodulator, that means envelope detector. But in this session I will explain the superheterodyne receiver. Before that, you must know about the what is radio receiver, what are the characteristics of radio receiver, and you must know about the heterodyne action. So what is radio receiver? Radio receiver is an electronic system which intercepts the transmitted signals and demodulates to get the information signal. That means it is the endpoint in communication system, and it is opposite in its function to transmitter. What are the characteristics of radio receiver? First one, sensitivity. Sensitivity, it is defined as the ability of a receiver to respond to weak signals. The sensitivity of a receiver is expressed in microvolts. Next, selectivity. Selectivity, it is defined as the ability of a receiver to distinguish between desired signal and unwanted signal, or it is defined as the ability of a receiver to reject a unwanted signal. Next is the fidelity. It is defined as the ability to reproduce the faithful in its output the signal that appears as input. Next, signal to noise ratio. It is defined as the ratio of signal level to the noise level. That means the noise may be due to internal or external. The ideal characteristics of radio receiver are, it must be high sensitivity, good selectivity, high fidelity, and high signal to noise ratio. Next is the heterodyne action. The heterodyne means it's a process of mixing together two signals of different frequencies to produce a set of new frequencies. That means the resultant out of this mixing contains the sum and difference of the frequencies of the two input signals. One is FC, Fs, that means this is the carrier frequency, and F0, this frequency is produced by the local oscillator. That means suppose the Fs is heterodyne with the another signal frequency F0. F0, this is produced by the local oscillator. That means local oscillator consists of tank circuits, that means which is a combination of inductance and the capacitance, which produces a particular frequency, that is F0. Then two additional frequencies are produced. They are F0 plus Fs and F0 minus Fs. Usually the sum is removed by the band pass filter. The difference is called intermediate frequency. Next is the AM superheterodyne receiver. The superheterodyne receiver is one of the most popular form of receiver in use today. Superheterodyne is basically a process of designing and constructing wireless communication such as radio receivers by mixing two frequencies together in order to produce a different frequency component called as intermediate frequency, that means IF. A superheterodyne receiver usually consists of an antenna, radio frequency amplifier, mixer stage, local oscillator stage, IF amplifier, detector. That means in this we are using the diode detector. Next, AF amplifier and a speaker. The working of superheterodyne receiver is explained with the help of this block diagram. In the superheterodyne receiver, the incoming signal to the antenna is filtered to reject the image frequency and then amplified by the radio frequency amplifier. This amplifier can be tuned to select and amplify a particular frequency Fs. Tuned means in this it is having tank circuit. That means it is combination of L and C. You know the frequency F equals to 1 by 2 pi square root of 1 by 2 pi square root of LC. This radio frequency can be tuned to select and amplify the particular frequency within the AM broadcast range. Only the selected frequency and its two side bands are allowed to pass through the amplifier. Next, the high frequency signal of received signal is called radio frequency signal and its frequency is radio frequency Fs and the local oscillator signal operates at F0. The amplified radio frequency signal is then mixed with the local oscillator frequency, that means Fs and F0. The combining of these two signals is done at the mixer stage, which produces sum and difference frequency signals of the incoming high frequency signal and local oscillator signal, which are Fs plus F0 and Fs minus F0. The sum frequency Fs plus F0 is rejected by the filter and the remaining difference frequencies signal, which is down converted frequency signal, is called as intermediate frequency. The frequency of local oscillator is not same as the frequency to which the radio frequency amplifier is tuned. Local oscillator is tuned to a frequency that may be either high or low than the incoming frequency by an amount equal to the IF frequency. Thus, idea of the superheterodyne receiver is to reduce the high frequency radio components of the incoming signal, it's a high frequency carrier signal, to a fairly low fixed value such as to be processed at the different stages of the receiver and also to provide good stability, gain and power, proper selectivity and fidelity. The modulation of the IF signal is same as that of the original signal, that means high frequency signal, and it has a fixed frequency of 455 kilohertz, which is amplified by one or more stages of the amplifications. That means the IF in commercial radio receiver is fixed to 455 kilohertz in AM receiver. The IF signal is amplified with the help of the IF amplifier, which raises its level for the information extraction process. Also, the IF amplifier fulfills most of the gain and the bandwidth requirements of the receiver. IF amplifier operations are different to the frequency at which receiver is tuned, maintaining the selectivity and sensitivity of the superheterodyne receiver considerably constant throughout the tuning range of the receiver. The amplified IF signal if is applied to the detector. This is the detector stage. To the detector to detect the information signal component from the 455 kHz intermediate frequency to reproduce the original information data, which is generally in the form of audio signal. The detector stage eliminates one of the sidebands which is still present and separate the radio frequency from the audio component of the other sidebands. The radio frequency component is filtered out and audio is supplied to the audio stage for amplification. So this is for audio stage, AF amplifier stage. The generated audio signal is then amplified to the AF amplifier to increase the audio frequency level of the signal and provide enough gain to derive the speaker or headphone. But in this we are using the speaker. A speaker is connected to the AF amplifier to play the audio information signal. An important part of the super heterodyne receiver is AGC, automatic gain control, which is given to the radio frequency stage, IF stage, mixer stage, IF stage and mixer stages in order to generate the constant output irrespective of the changing the input signal. That means the volume of the loudspeaker is kept constant by using the AGC. The output of the radio receiver depends on the strength of the incoming radio frequency signal. Therefore, a weak input radio frequency signal provides a low output, and a high strength input signal, radio frequency signal provides a high output. To control this output to a constant value, AGC is used. Super heterodyne receiver, that means next is the name gang tuning. The name gang tuning. In this 3 stages having a tank circuit, that means combination of inductors and capacitors, 3 stages, this stage and this stage having a tank circuit, that means combination of inductors capacitor to produce a particular frequency. The capacitor in these the 3 stages are simultaneously changed to produce the intermediate frequency signal by using a gang capacitor. Super heterodyne receiver in spite of being more complicated than some of the other receivers offers many advantages in terms of performance, most importantly the selectivity. It is more efficiently able to remove the unwanted and distortion signals than other forms like tuned radio frequency and other receivers. Due to the enormous advantages provided by the super heterodyne receiver compared to the other radio receiver, they are widely used in the all broadcasting radio receivers, commercial radios, as well as the televisions operate on the basis of the super heterodyne principle. Thank you.